Good afternoon. Okay, rather. Yeah. So yeah, it's already 1 p.m. No, and we're gonna formally start now the webinar. No. Yeah, but there are other like participants. No, we're still accepting not to join the Zoom meeting. There's so many na nag-register dito sa pre-webinar, and of course may prizes as like the way of our giving back to our clients. So may raffle tayo at the end of the webinar, like 1,000 pesos GCash each of the winners. So 10 winners yon. So may raffle tayo at the end. And ang may like certificates from us, yung Xstructures certificates ay for the first 100 registrants. So apologies kasi medyo tedious talaga yung waga sobrang dami niya ng work. So although it's a pre-webinar, so 100 lang yung magkakaroon na, yung first 100 registrants yung magkakaroon ng certificates from Xstructures. Yung 101 to 1,000 ay Bentley certificates. So yun, galing kay Bentley naman yun. So directly you're gonna register may isa-send kaming link sa inyo kung paano nyo makiklaim yung Bentley certificates. So which is sobrang dali lang nun. Mag-register ka lang and then you download your e-certificates from Bentley systems. But for those naman yung more than 1,000, yung more than 1,000 na nag-register, actually 3,000 yung nag-register. So that's why we open yung FB Live now, So yung 3,000 na nag-register before the 1 p.m. ang cut-off namin ngayon is 1 p.m. So basta pumasok ka doon sa registration time na yon, so you can watch you can watch yung webinar through FB Live, and you will still get the Bentley e-certificates as long as nag-register ka doon sa provided na link. So just to serve lahat ng nag-register kasi kumbaga, even if let's say nag-register ka, you don't know na ganito na karami, so but still you like use your time para mag-register, so yeah, we consider that. So you can watch the webinar, you can tell your friends na pwede siya sa FB Live, and then as I've said, they can get Bentley certificates. Yun. So it's yung more than 1,000 yan, kasi sobrang dami ng nag-register. Okay, so we're gonna start now like formally our webinar. So welcome to this webinar. And yeah, first of all, so thanks for registering to our webinar, and hopefully marami kayong matutunan dito sa webinar na to. And yeah, it's all about like response spectrum analysis procedure per Nscp, theoretical background with our like highly technical speaker, si Engineer Juan Paulo Bersamina, so together here with us. And meron tayong Staad applications later, which I'm gonna be doing after Sir Paulo. Then after that, yung last part would be the raffle. Ang dahil nagme-message sa akin sa Facebook, but anyway, yun, lang naman yun. It is as much as we want to manalo kayo lahat, but ayun, so kumbaga 10 lucky winners lang yung ating pipilian. Okay, just a quick introduction of our company. So we are Xstructures, when we are in partners with different software developers, and currently we do have 3 offices all over the Philippines. Our head office is in the Ortigas, although we have still we have the small office in Makati, but the bigger one is in Ortigas, and we have in Cebu, in Banilad area, Then in Davao, no, I'm currently here in Davao, no. Galing ako ng Cebu, no. But this webinar kasi yun natapat sa travel, no. I'm currently now here in our Davao office, no, delivering this online webinar, no. And we are near here at SM Ecoland, no, in Davao City. Yeah, so me and Engineer Paolo Bersamina, no, so we're gonna be your speakers for today, no, webinar. And my name is Engineer John Paul De La Rosa, so I'm the one managing the Xstructures, no, for more than 4 years now, no. So, but prior to working on full time with the Xstructures, I used to work with Bentley Systems, no. So si Bentley Systems ay ang developer po ni Staad Pro, no. So I used to work as technical person like for 4 years, and the rest 4 years I work as account manager, no. So in Dubai, UAE. So if you're just interested, no, to like avail our offered books, no. So we do have 3 available books in Staad Pro and Staad Foundation, no. So all available in Shopee and Lazada. Yun. Although meron kaming mga stock sa office, no, you can also drop by to our Ortigas office. But in Cebu and Davao wala po, no. But in Ortigas office, nandun lahat ng supplies namin, no. You can drop by and get the copies there, but pinakamabilis talaga is you order from Shopee or Lazada. About our company, no, so we are Xstructures engineering consultants, and as a company, we're offering like multiple services. No, we are structural engineering and BIM consultancy company. We are also into training, where we are PRC accredited CPD provider. No, and apart from that, so we are also selling softwares, no, so licensed software. So if your company has a requirement, no, on Bentley, SeismoSignal or ZWCAD software, no, so you may contact us, no, for your requirement. As I've said, office and training center locations, Ortigas, Cebu, and Davao City. And this is our Facebook page, no, feel free to visit. Anyway, nandyan din yung aming FB Live link, no, sa aming Facebook page. And as a company, so we are selling these softwares and trainings, no, from Bentley, ZWSoft and SeismoSignal, no. So for Bentley, all structural softwares like Staad Pro, RAM, the RCDC, no, Plaxis, and so many more, no. And ZWCAD naman for drafting tool, no, as alternative to AutoCAD, no, on perpetual license based software, no. Ayun, you may contact us if you have requirement for ZWCAD, no. Very reasonable price software. And then for assessment and retrofitting design of existing structure, no. So we're offering SeismoBuild and SeismoStruct software. So we are SeismoSoft official partner, no. So so si SeismoBuild and SeismoStruct are the only software, no. So what I mean with only, no, so siya lang yung direct software or direct software solution, no, for assessment and retrofitting ng existing structure, no. So yeah, so when you assess a structure and then subject to intervention or retrofitting, no, like using ng FRP, no. Wait a second. Okay. Wait a second. Yeah. Second. May nagano lang. May lumulusot. Okay. Yeah. Ako lang. Ayan. Okay. Yeah, so this is the only software, no. So although you can use other software, pero may you're gonna be using additional like Excel, ano, yeah, Excel. Okay. Ayan. Yeah, so you can use other software, no? For assessment and retrofitting design, no? So kaya lang hindi direct yung solution, plus there's so many workarounds, no? So but with SeismoBuild and SeismoStruct, no, as I've said, the only solution currently in the market that can do assessment and retrofitting design of structure, no? Yan, kung kailangan ng FRP, concrete jacketing, no? And steel jacketing, no, ng elements, no, so you can do it with the program. And then so we are a SeismoSoft official partner here in the Philippines, no, so we distribute said WCAD software, no, as you can see on the screen. Yan yung interface ni said WCAD, no, so we know AutoCAD is very popular, no, so but alternatively, you can also use ZWCAD, no, as your alternative tool, no. Ayan. Then we are Bentley authorized channel partner. We are Bentley channel partner in the Philippines, and Bentley has so many softwares, no, as you can see on the screen. More than 300 like very powerful softwares that integrate together, no. So I think Bentley is the biggest software developer, no, or biggest software supplier globally, no. So when it comes to software solutions, kahit anong industry yan, buildings, bridge, geotechnical, or sa rail, no, power plants, project management, no. So Bentley has all solutions, no, for those different industry, no. So but for us naman, no, so we are focusing more on structural roads, no, bridges, geotechnical, no. So yeah, so we are selling those software, but we can also supply you other other Bentley software, no, if you have requirement. So here are some of the softwares, no, that we are able that we are supplying here in the Philippines. Of course, the Staad Pro, RCDC, RAM connection, Open Roads for road design, no, Open Bridge for bridge design, then Plaxis for geotechnical analysis. And here are some of our the partial list of our clients for Staad Pro and SeismoSoft, no, softwares, no. So these are the partial list, but when it comes, Staad Pro is the #1 software here in the Philippines, no. So like because of its easiness to use, no. Napakadali niyang aralin, no. You can also even self-learn by yourself, no. So very easy to learn, even me, no, when I starting using it. So it's very easy to learn, very user friendly, no. So that's why yung popularity ng Staad Pro, it's because of that, no. Yeah, and so many licenses here in the Philippines, no, and so many companies are using Staad Pro, and as well RCDC and RAM, no. We are a PRC accredited CPD provider, no. So we're delivering CPD like approved CPD trainings, which is this one, no. Like what we are doing today, no, may approved na 1 point ito, no. But before the pandemic, no, we are delivering this kind of trainings, no. Before pandemic, minimum we are having 30, 50, no, even 200 attendees, and even 300 attendees, no. When it comes to CPD trainings, no. Yon, before pandemic, where ngayon kasi like this one, so online, we are comfortable doing online webinar, no. So but before, most of our trainings, no, or seminar are into face-to-face basis or classroom or hotel basis. Then just last January, no, this year, no, so we delivered 2 trainings to DPWH, no, hybrid training, online and on hotel type training, no. So where we had almost 500 attendees. So we delivered Staad Pro advanced training, no, with dynamic analysis there, together with the Seismo build, no, seismic assessment and retrofitting of reinforced concrete buildings. So here are some of the actually so many trainings that we are delivering on monthly, no, or offering on monthly basis. More than 50 trainings, no. We're operating on monthly basis, no, and we're offering trainings to different like civil engineering specialization or major, no, or even to other professionals, architecture, some mechanical engineering, electrical engineering, no. So, but when it comes to civil engineering, no, we have so many specialization. Kung structural ka, kung project management, no, geotechnical, transportation, no. So we have trainings for you, no. So which is maybe one of the trainings we're offering on from the on what you are seeing, no, on the screen. Okay. Okay, so we are Autodesk Authorized Training Center, no? So we are able to deliver, no, most of Autodesk products training, no. So we have the AutoCAD, complete yung Revit, no, Revit training we are offering. We even have advanced Revit training as well, no. We have the Plan 3D, Navis work, no, Infra works, no. So we even have 3D Max, no. And 3D Max for building application, no, building design application, and 3D Max for animation. So we even have those kind of training. And these are the sample trainings we delivered from the past. I believe Sir Paulo also are here, no? Okay, on this one of the trainings, no. But I used also to deliver trainings as well, no. Me and Engineer Paulo Bersamina, no. So we're traveling all over the Philippines. Yeah, and so since this is focused on Staad Pro, like application, no, application, no, on response spectrum analysis, no. I just want to discuss this like short history of Staad Pro, no. Staad Pro as acronym for Structural Analysis and Design, no. It's a general purpose structural analysis software, no, program, no. It is capable of performing static, dynamic, and nonlinear analysis, no, and can be used to model and analyze most of any types of structures, no, ranging from buildings, bridges, no, containment tanks, underground structures, stadiums, telecom, and transmission towers, no. So we actually have training, no, last week ng telecom and billboard design, no, using Staad Pro, no. Then Staad Pro is a program written and developed by the late Amrit Das in the 70s, no, under his company Research Engineers International, and then acquired by Bentley in 2005, no. Staad Pro is one of the first structural analysis and design software that take advantage of iterative design and conducive to the workflow of a personal computer, no. So as of today, Staad Pro is one of the most widely used structural analysis and design software products globally, no. Some of the world's greatest pieces of infrastructure, from bridges to skyscrapers to stadiums to historical monuments, were designed using this program, no. And what you're seeing on the screen, no, so that's Amrit Das and his son Antonio Das, no, which is the Chief Business Officer and Senior Vice President of Bentley System. No, the Staad legacy still continue under Bentley systems, and used to have the photo opportunity with Santanyo Das. No, when I was with Bentley systems. And not only Staad Pro, no, when it comes to structural analysis program, ang offerings ni Bentley, no, so there is RCDC, no, I know you know, like the RCDC for concrete design, very powerful software for concrete design, no, up to detailing and bar bending schedule, and Staad Foundation for foundation design, no, so you can design isolated footing, combined footings, no, piles, no, you can do pile analysis with Staad Foundation, no, so if you want to calculate pile capacity, no, so you can use Staad Foundation, or let's say skin friction capacity, end bearing capacity, or the combined capacity, no, so the program can do it for you, no. RAM structural system naman is a concrete and steel building structure design software, no. Then RAM concept for slab and mat foundation design, but not only that, no, so it can also design post-tension slab, beams, and mat foundation as well, no. And when it comes to steel connection design, no, like the joint design, no, of steel, RAM, you can use RAM connection, no. It's also Bentley software. And integrates well, no, with Staad Pro, no. When you have the steel structure and you want to design the connection, no, between elements, no, so integrated yan kay Staad Pro, and you design your connection, shear connection, moment connections, or even base plate, no. And RAM Elements, one of my favorite software, no, for pre-engineered building structure, and together with some toolkit mode to design retaining walls, wood elements, no, wood components, masonry structure, and cold form structure as well, no. And iTwin analytical synchronizer, no, so if you want to transfer like Staad Pro or yung mga BIM software ni Bentley to structural software, no, so this is the tool for that. And you can also use the iTwin analytical synchronizer to transfer Staad Pro to non-Bentley software like the Tekla Structure or Revit, no, or Autodesk Revit. So here are some of the projects, no, I just okay, like I compiled, no, that were designed using the Staad Pro. And most of these structures are monumental structures abroad, no. So because I work in Dubai, UAE, no, for so many years, no, here are some of the like monumental structure there, no, designed using the Staad Pro, no. So the Abu Dhabi airport, no, in Abu Dhabi, UAE. No, so Staad Pro is just for not for simple residential structure, no. Monumental structure, kayang-kaya yan, no. Like the Abu Dhabi airport, no, like the Nakil Mall, no, in Palm Island, Dubai, structure, no, where and then the Mohammed bin Rashid Library, no, in Dubai, UAE, no. So there's so many analysis has been done there, no, in place analysis, no, construction stage analysis, no. So they use Staad Pro, no, to analyze this structure. As you can see the shape, no. So kakaiba yung kanyang shape, no. And even the Dubai Canal pedestrian bridge, no, ayan, so tinwist niya, no, nakatwist yung pedestrian bridge, no, pedestrian bridge na mayroong art. And the Ferrari World Abu Dhabi, no, so combined plate, no, and beam elements, no, so build in Staad Pro and analyze and design, of course. And then with that, no, I'm done with my presentation. And we're gonna go to the theoretical background, no, of the response spectrum analysis procedure of Nscp. And with that, no, I'm gonna be turnovering the meeting room to Sir Paulo Bersamina. Hi, Sir Pau. Hello, Sir Pau, your turn. Maybe nagse-set up pa ng...
Yes, sir. Hello,
yeah,
good afternoon, everyone.
Ayun, okay.
Yes, hello, sir.
Yeah,
Okay, so...
okay. Sir Paulo currently in Manila, no. Nandito naman ako sa Davao. Okay. Yeah, because of travel duties. Okay.
Okay, sige. I heard na introduce din naman ni Sir JP yung ano kanina, no? Yung software na Seismo build and SeismoStruct, no? And he told us that currently, no, sa market siya pa lang yung software to cater the retrofitting design. And this topic, no, this afternoon is very important, no, because when you do retrofitting design, kailangan knowledgeable ka sa response spectra. And we're going to discuss that. Okay. So let me now share my screen here. Yeah, so I grab our template, no, from Xstructures. Yeah. So yeah, since I'm also currently an assistant professor too at TUP Manila, I also teach full time, no, in undergraduate, and I also do teaching in masters. No, if you ever wanted to enroll, no, sa TUP, and even in in Xstructures also. I'm a resource speaker, no, for some short courses like earthquake engineering, matrix analysis. Okay, for the codes and references, no, of course, this is Nscp 2015, no, but we all know that our code is patterned after UBC 97. And we also reference from other code like ASCE. Yeah. But for the theoretical part, no, mostly I will be using the book from Chopra, no, Dynamics of Structures. And in most earthquake engineering courses, no, itong book na to ang madalas na gamit. That's why it's sometimes called the Bible of earthquake engineering. And I also gonna use some from module from NPTEL and a bit of of the flow discussion from Dr. Fawad Najam, his YouTube channel. By the way, I also have my YouTube channel, Paulo Bersamin, searchable naman po. Okay, first, no, what is dynamic analysis? So we have to identify, where do you use static and dynamic analysis. By the way, the response spectra is naka-umbrella siya sa dynamic analysis. Okay. Now, the static analysis, since we are all either civil engineering students or civil engineering professional, the minimum, no, that in our undergrad natuturo na sa atin tong static analysis, no? And it's applicable for all structures, no, in occupancy category 4 and 5 in zone 2. Okay. When we say zone 2, no, it's maalala agad natin dyan yung bandang Palawan, no, Sulu, Tawi-Tawi, no, ibig sabihin zone 2 sila. And by the way, zone 2 means it has a peak ground acceleration of 0.2 g. Yeah, so generally ganun, no? Meaning, we're expecting when an earthquake hits, no, the max lang siguro na made-develop is 0.2, okay, 0.2 g. Okay. Whereas if you look at the zone map, no, of the Philippines sa Nscp, about 90%, di ba? Zone 4. No? Meaning, yung PGA naman nun is 0.4 G. Okay, so ganun kalahas. No? Okay. What else? No? Static analysis is also applicable for regular structures under 75 meters in height. Okay. And also irregular but not more than 5 stories. That's why sa kabila, mapapansin nyo, kailangan mo na yung dynamic analysis over 5 stories or 20 meters in height. Okay. And then for another criteria for dynamic is 75 meters or more in height, because here, ito naman, less than 75 meters, no, sa static analysis. Okay. And another major difference is when your structures have a stiffness, weight, or geometric vertical irregularity. Yeah. So kailangan mo ng mag-dynamic analysis. Okay. And of course, when you are located on soil profile type SF. So yan yung pinakamalambot na lupa, no, dun sa table natin sa Nscp. Okay. Okay, so sabi ko kanina, no, the response spectrum analysis naka-umbrella sa dynamic analysis. So now, when you qualify for dynamic analysis, so meaning if your structure is irregular, no, and it's 5 stories or more, no, so you will either you perform the response spectrum analysis or the time history analysis. Okay. So what is this response spectrum analysis? It's an elastic dynamic analysis of structure utilizing the peak dynamic response of all modes. Okay. Having a significant contribution. That's why later, no, we will discuss the modal periods, no? And then we will discuss how significant, no, yung contribution ng mga modes na yun to the total structural response. Okay. Okay, so the response spectrum defines the maximum relative linear response of a single degree of freedom system, no, excited by a given strong earthquake ground motion. Okay, so nade-develop si response spectra, magsasubject ka ng an earthquake ground motion sa SDOF. So from the word single degree of freedom, no? So let's say meron kang structure, elevation view, then we idealize that as a single degree of freedom. So parang lollipop, no? Yeah. Let's say i-lump natin yung masses. We have mass here. I-lump din natin yung stiffness. Yeah. And then you subject that to an earthquake ground motion. Siyempre, yung ground motion yun, erratic yun, no? Hindi siya parang harmonic excitation. So, ano siya, irregular yung mga, ano niyan, no? Itsura niyan. So, then, this graph shows the acceleration, displacement, and velocity responses, no, from low rise to high rise. Okay? Then, when you look at the book ni Chopra, no, ang pinaka-famous na ginagamit doon is the El Centro ground motion. Available na yan sa Google, makikita nyo na yung data niya. Okay? But syempre, technically, we can use different ground motion. No? Let's say, nagkaroon ng earthquake sa Abra, sa Pampanga. No? You can inquire sa pivots. No? Kunin mo yung ground motion na yun, and you can subject to your structure for, no, as an exercise to see, no, what will be the response, no, yung dinesign yung building. Okay? So, and what else? No, single degree of freedom system. So you will do this kind of excitation to a lot of SDOF. No, and as a rule of thumb, no, as an approximation, no, lagi kong sinasabi sa mga students ko, no, the period of a structure is roughly, no, 0.1 of the number of floors. So ano natin, no, i-set natin yung mind sa formula na, sa ganyan, no. So for example, meron tayong 2-story. So what could be the approximate period? So 2-story can be 0.2 seconds. Yan. Para makita natin yung ano, ma-visualize natin. No? So when we say a single degree of freedom structure having a 0.2 second period, that's 2-story. Now when it's 0.3, that's 3-story. 0.4, 4-story. No? 0.5, 5-story. I believe yung mga designer dito, no, pag nagka-project kayo, subject niyo yan sa Staad, ETABS, no, you will see roughly ganyan nga yung nakukuha yung period. Even if you use the approximate formula from Nscp, CTH raised to 3/4, you will get roughly the same period. Okay? So when we say 0.5, that's 5-story. And 10-story, roughly 1 second. Okay? So ibig sabihin, you will subject that ground motion to a lot of SDOF. From 1-story, 2-story, 3-story, so pataas ng pataas. Yan. Okay? And then, we will get the peak responses. No? Yung sabi kanina sa definition. Okay. Okay, and so that's for the response spectra from a specific ground motion. Okay. When we talk about the code, no, meron ng pre-provide si code na response spectra. So ito naman yung gagamitin natin for design. Okay? But before we go into that, no, I would like to, syempre theory muna tayo, no. We would like to create the response spectra from a specific ground motion. Okay? Okay. So what's the ground motion? The ground motion representation shall as minimum be one having 10% probability of being exceeded in 50 years. Okay. Well, this is ano, code based na to, no? Ito yung sinabi ni Nscp. But just to give context, no, when we say 10% probability of exceedance in 50 years, minsan gusto nating kino-convert into return period. No? So, anong shortcut ko dyan is basically 50 divided by 0.1 kasi 10%. No? So, that's roughly 500 years. Kasi to be exact, that's 475. So, ibig sabihin, we're designing our structure. Kapag ginamit mo si Nscp, no, dinidesign natin yung structure natin for a 475-year return period of earthquake. Okay, so yan yung nakalagay sa code. Okay, and then sabi ni code, an elastic design response spectra having a values of CACV. I believe, no, alam natin yung pagkuha ng CACV, no? Kailangan meron muna tayong value ng NANV, di ba? So from the distance to the fault line, no, having a soil type, no, makukuha natin si NANV, and also si CACV. Pag na-capture na natin yung CACV, mako-construct na natin itong response spectra. But this is what we call code-based, no, or design response spectra. Okay, okay, next. Yan. So ito nga yung a very quick application niya, no. Once na nakuha mo na siya, na-generate mo siya dito, I'll show you a spreadsheet later, no, paano ma-generate ng mabilisan. Once na na-develop mo na siya, i-import mo na yan, yung coordinates niyan dito sa ating Staad. Para yun yung gagamitin ni Staad to determine ano yung i-apply niyang spectral acceleration. And by the way, ito nga yung ating zone map, no, sa Philippines, no, zone 4, and you will see roughly, no, 90% no. So again, to give context, no, ibig sabihin once na nasa zone 4 ka, no, dapat, no, the code implicitly requires that your structure should withstand a PGA of 0.4 G. To give you an idea, ano ba yung 0.4 G? Yung nangyaring Abra earthquake, no, as per the record ng PVOX, that's only 0.2 G. No, bandang Ilocos, no. Of course, epicenter, we don't have record yet, no, officially, no. Pero yung yung nangyari sa yung na-detect no nung pivot sa location nila is 0.2 G. But imagine the destruction. Tapos i-require sa atin ni code 0.4 G pa, no? Well, of course, if you read the code, no, ina-expect naman ni code ng inelastic deformation. So ibig sabihin, code expects cracking, no? Code expects damage, no, but not collapse. Okay? Ayan. So again, so we'll stick to a response spectra generation from an actual ground motion. Doon muna tayo, no, para mas maintindihan natin yung code base. Okay? So sabi dito, no, let's subject SDOF with different periods. So for example, ito 0.5 seconds. So again, yung formula natin, no, 0.1 n, sabi natin that's roughly 5 story. No? So subject natin yung 5 stories sa El Centro ground motion. Okay? And by the way, no, the El Centro ground motion has a PGA of 0.3 G. So medyo malakas-lakas yan, no? Ito, andito yung ano niya, max niya. Yan, andyan yung 0.3 G. Okay. Then sabi dito, no, if you subject that 5-story, no, with an assumed damping of 2%, no, you will get a peak deformation of 2.67 inch. Okay, but we will go back later dyan, no? But I'll show you what's the mathematics behind, no? Ano ba yung mathematics niyo? Ayan. Well, sabi ko nga, no, the ground motion is not a regular curve, no? Hindi naman siya harmonic, no, sine cosine, no? That's why you need to employ numerical methods. Okay? And you can use central difference method. Okay? And this equation, no, shows that the response, no, the response U, yan yung displacement, no, is basically a function of what? This is the damping ratio. And this is the frequency. Yeah. So kung alam mo yung damping ratio ng structure mo, alam mo yung frequency or the period, makukuha mo na yung displacement. Okay. But first, how do we get into that? No? Ang ginagamit kasi nating equation of motion is this, no? M U double dot plus CU dot plus KU equals force, no, as a function of time. No? So let's divide both sides by M. So, may M dito, may M dyan. Okay. So maka-cancel out to, no? Cancel to. So matitira is U double dot plus C over M, U dot plus K over M, U, the displacement, is equal to, well, this force, no, can be rewrite as force is mass times acceleration, right? No? The mass times acceleration. So mass times which is the ground motion, no? U double dot G. So meaning yan yung ground motion. And meron kang M dito. So maka-cancel out din siya. Okay? Now, this equation here is actually equal to this. Yan. 2 damping ratio, then frequency. So, yan, you double dot. And this equation, no, familiar kayo dyan, no? Ang formula kasi ng period is 2 pi square root of M over K. Okay. So, that is your frequency. You know, so when you're dealing with M and K, that's your frequency squared. Kasi omega is equal to square root of K over M. But omega square, so mawawala yung square root. You know? Kaya meron kang omega square. U is equal to the ground motion, which is now equal to this. Okay, so pinakita ko lang yung derivation na it shows that this equation came from the equation of motion. Okay. Now, so bakit natin kailangan central difference? Kasi nga, erratic yung ano natin, no? Yung ground motion natin. Okay. So, let me clear. Hindi ko naman mabura. Ayan. So, first, kasi kailangan natin, makikita nyo, you need the acceleration, you need the velocity. No? Ayan. For the velocity, no, alam naman natin, no, velocity is y first derivative, diba? or rise over run. So u dot is equal to rise over run. No, so kung ito yung curve natin, yan. So what's the rise? Basically this is time, no? This is time. This is the displacement. Ui plus 1. Ito is u sub I minus 1, no? So kung i-zoom in natin tong ano na to, tong curve na yan, you have this trapezoid. Yan, no? Yan. And then rise, ito yung rise natin, which is yung ui plus 1 minus ui minus 1. No? That's value. Then how about the run? No, the run is, you notice if this is delta t here, ito is delta t, this is delta t again, so na-occupy mo 2 delta t. So that's 2 delta t. So yan yung formula ng velocity. So yan yung velocity at sa gitna. No, kasi nga, we use the central difference. Central, pinagitnaan natin. No? So ito yung velocity at that location. How about the acceleration? No? Well, medyo tatagal yung derivation. No? Basically, you just need, di ba, acceleration is basically dv dt, no? Changes in velocity over time. Di ba? So, kailangan natin makuha yung changes ng velocity naman. Kaya makikita nyo sa formula, you need to find the changes ng velocity. Okay? Velocity, so pagigitnaan mo din, no? Pagigitnaan mo to. Ano ba yung pumagitna sa kanya? Yung velocity at I plus 1/2 at velocity nung I minus 1/2. So, kukunin mo yung formula nun. Yan. Okay? And then yung na-occupy niyang run is delta t lang. Okay? Kasi sa gitna, di ba? Yan, ito. Yan yung delta t. Yan. So, employing the same methods, no, kagaya dito sa velocity natin sa UI, except this time, kunin mo naman yung velocity ng I plus 1/2 and I minus 1/2, ito makukuha mong formula. Yeah. And then substitute, no, then algebra lang, you will get this formula. Yeah. So yan yung formula ng acceleration. Okay? Next. Ayan. No? So sabi natin, no, yung formula ng equation of motion is ito. Mu double dot plus Cu dot plus Ku equals force. No? So nakuha na natin yung formula ng acceleration earlier, di ba? So ito yun. Yan. Kuha natin yung formula ng velocity. Plug in natin doon sa formula. Yan. Okay? And then algebra lang, no? Find the common terms, no? Until ma-simplify natin into this. And then ito na yung pinaka-algorithm ng central difference method. I got this from Chopra again, no? Yan. Mukhang madami, no? Pero lagi ko sinasabi, no, sa mga students ko, no? You will notice itong k hat term, A, B, constants na yan. Constants. Because given yung mass, no? Kasi kapag meron kang SDOF structure, syempre kailangan alam mo yung mass. Okay? Mag-assume tayo ng damping, no? Damping coefficient. Given din yung delta T. Kasi nga, kung meron kang ground motion from P volts, no? Normally, given na yung ano doon, time increment, yung records, no? So ikaw magsiset yan, no? And also, may kita nyo naman yung formula ng A and B. Ganun din, it's a function of M, C, delta T, ganun din yung T. No? So, yung mga yan constant. No? And you do it iteratively yan, to compute for the response. No? And so, ito yung sample output sa spreadsheet. Okay? So, that will para malaman nyo no, how in-operate siya. At least, alam nyo, no, lahat tayo marunong sa Excel, no? Engineers tayo. No? At least, hindi kayo takot na ganito lang pala, no? Ganito lang pala mag-derive no, ng response spectra manually using spreadsheet. Okay? And then, ayan. Mamaya pakita ko yung sa spreadsheet. So, for example, ito. Inopen ko na siya rito. Ayan. Hope nakikita niyo siya. Ayan. So, for example, no, 5-story. Ano nga ba yung nasa ano kanina? Nasa 5-story. Ayan. 0.5 seconds. Ayan. So, if I zoom in here, 0.5. Okay? So, yan yung formula, 2 pi over the frequency. Tapos, let's say this is your given mass. Ito yung K, no? Just to get the 0.5 period. Ito yung ating central ground motion. Yan, and yung central ground motion. So, makita nyo, ito yung PGA. 0.29 or 0.3 at 2.2 seconds. Tapos ito yung 0.32 G, no, at 2 seconds. Kita nyo, no? 2 seconds nangyari yung peak ground acceleration. Okay? Then, ito yung ating, this is 5-story, no? Sinubject mo sa center ground motion. Ito na yung kanyang time history response. And as you notice, no, where did the peak response happen? No? Makita nyo, the peak response occurred at the vicinity ng 2 seconds. No? Ito, 1.88, 2 seconds. Ito, yan. 2.27 at 2.32 seconds. Okay? No? So, halos sabay eh. No? Kita nyo, no? Halos sumabay yung PGA dun sa peak response, no, of the 5-story structure, 0.5 seconds. Okay? So, balik tayo sa ano. Yan. So, sir, medyo hirap kami sa sa spreadsheet, no? Pwede rin sa Staad, no? You can do it in Staad also. For example, you model in this one, no? We try to model a frame, no, having a period, say 0.5, no? Okay. Yan, yan. How do I know na 0.5 yan, no? So, as a basic, no? Yan, okay. So, let's say I have a mass or 140 kilonewton lump mass, no? Convert mo sa mass, no? That's divide by 9.81, no? Ito na yung corresponding mass mo. Then, let's say meron akong column na 150 by 100, ito, yan. Okay, sa dalawang poste. So, the stiffness of that is 12 EI over L cubed, no? Times 2, ito na siya. And therefore, meron ka ng K. Meron kang M, mass, meron kang K, mo ko may frequency. Convert mo sa period. And this is your corresponding period. Okay, so that's 0.5. Okay, so gawin natin sa Staad. Example. Properties. Ito yung ating, 150 by 100. Ayan. And then, naglagay lang ako ng rigid na element para masiguradong walang rotation. And then I have a loading. Yeah. So to have a 140 kilonewton mass, no? Naglagay ako ng tig 70 on both ends. No? Then you perform this command, yung modal calculation, ibig sabihin, computing niya yung period, no? of your model. Yan. Tapos itong ground motion, no? Yan yung el centro, no? So to apply that, punta ka sa time history. Hindi ko napapakita kasi tatagal tayo. So ayan yung ating, oops. Yan, yung el centro. So consistent, ito yung PGA. Okay? Ang el centro about 30 seconds. No? So magde-define ka ng time versus acceleration. Tapos itong maganda sa Staad, you can just copy paste, no, from Excel yung data ng earthquake. Yeah. So that's it. So nag-subject ako ng el centro ground motion sa isang frame having a period of 0.5 seconds. Okay? Okay, yan. So sige, run natin. Analysis, run analysis. Yan, so done. Then punta tayo sa post-processing. Okay. So dynamics. Yeah, kita nyo, no? Yung na-compute din yung period is roughly 0.5, no? 0.52 seconds. The same lang, no? Then if you wanted to find the time history response, no? Layouts, displacement. Pinapatanong ni Staad, no? Anong point, no, sa frame mo yung gusto mo makuha yung displacement. So magpipick ka ng node. So ito na yung response, no, of the frame. So you can imagine, no, you can do this also sa model niyo, no? Except syempre naka 3D. Ako 2D lang para ma-demonstrate ng mabilis. And so roughly you will see nangyari yung peak displacement at about same time din, no? May konting lag lang, no? 2.35 seconds, we obtain a 74.3 millimeters. No? Pag kinonvert niyo yan sa inches, roughly 2.5, no? Ganun, 2.6, 2.5. Okay? So almost the same. Okay? So balik tayo sa 0.5 seconds. Yan. Yan. So which is ito din, no? 2.27 inch. Yun naman nakuha natin sa spreadsheet, employing central difference method. So I'd like to say that ang software ganun din. No, it uses numerical methods. So most likely Newmark's method. No, tayo pinakita ko lang central difference. Okay? Okay, so that's number 2, no? And another way to quickly obtain the time history response, no, we can use the software SeismoSignal. No? So fortunately for me, no, as provided by Sir JP, no, Xstructures, meron din akong SeismoSignal sa machine ko. Yan. So for example, like we have this, yan, inano ko na yung central ground motion. Where is that? Yan, naka-input na, no? And then ito yung response spectra niya. Meron na siya, no? Pero papakita ko lang yung time history response, no? So ayan, you can set the damping ratio, you can set the period kung ano yung gusto nyong hanapan ng time history response, no? And then get the response, which is displacement. Okay? So yan, kita nyo, no? Same response, no? Na yung peak niya is nandun sa roughly sa 2 seconds. Okay? Ayan. So balik tayo dito. Yan yung quick procedure. Yan, using SeismoSignal. And then when you do that, no, you can generate this response spectra. Okay, so halimbawa, di ba? Sa 5-story, ito yung nakuha natin, roughly 2.67 inch. How about sa balikan natin dito. Yan. How about sa 1 second or 10-story? no? 10 story. Balik tayo sa SeismoSignal. Palitan ko ito ng 1 second. Ayan, refresh. Ayan. So, ito yung at kanyang peak response. That's roughly 5 point. Yan. This is 5.5. Almost 6, no? 6 inch. No? And ano yung nakuha dito sa ating slide? 6 inch. Okay? So, the same. No? And then for 2 seconds, no? That's about 20 story, no? 7.47 inch. Balik tayo sa SeismoSignal. 2 story, 2 seconds. 20 story rather. 2 seconds. Then refresh. Yan naman yung kanyang peak response. Yan. So, makita nyo, ano niya. That's about 7 inch. Ito, 7.5. No, 7.5. Yeah. So, halos the same. No? 7.47 inch. Okay. So, yun, no? You can use Staad, you can use numerical methods in the spreadsheet, and you can use SeismoSignal. And mapaplot nyo na yung mapaplot nyo na yung displacement response spectra. Yan. So, mapapansin nyo, no, roughly, yung trend pataas. No? Habang tumataas yung building, tumataas din yung displacement. Okay? And then, to get the velocity and acceleration response spectra, ang gagawin nyo lang naman is, di ba, ito nga yung displacement natin. Ang formula lang naman doon is P is equal to omega T. Multiply mo lang yung displacement sa frequency. And then to get the acceleration, omega square T. Okay? And yun nga, when you do that, ito yung lalabas na acceleration response spectra. Okay? But before we go into gusto ko lang i-emphasize again, no? So mas mabilis kasi dito sa So what do you notice, no? Yung 0.5 seconds, 0.5 seconds is that yung peak displacement niya nangyari at about 2 seconds. Yung 1 seconds, sinin niyo. Refresh. Saan yan? At about almost 5 seconds. No? Okay? Then yung 2 seconds, 2 seconds, so yung 20 story, refresh, lumayo. No? So roughly 11 or 12 seconds. Okay? So, ano yung sabihin nun? No? That, balik tayo dito sa yan, no? So ibig sabihin, no, habang yung structure natin tumataas yung period, no, nagkakaroon ng lag, no, from the PGA, no, up to dun sa peak displacement niya. So itong 5-story building natin halos sumasabay, no? Sumasabay dun sa PGA ng ating center ground motion. Okay? Tapos yung 20-story building na experience niya yung peak displacement 10 seconds pa. No, about 8 seconds after nung PGA. No? So that's one of the reason, no, to discuss this response spectra, no? So mapapansin nyo yung mga low period structure natin, no, let's say ito 0.5, no? Tingnan nyo yung acceleration niya. Umabot ng 1.1 G. Imagine nyo gaano kataas yun, no? 1.1 G. Okay? While yung 20-story building, no, 0.2 G lang. You can imagine, no? Yan. So ibig sabihin yung mga low-rise building, ang tendency, makaka-experience sila ng peak acceleration. Yan. Tapos yung mga high-rise building, ito, no? Yan. Low acceleration siya. Okay? And when you look at the displacement response spectra, of course, yung mga high-rise building or mid-rise to high-rise, syempre, high displacement. So parang, can imagine, ang bagal sa taas, pero ang laki ng displacement. Yan. That's why, yung mga mid-rise to high-rise natin, ang tendency, babantayan mo sila yung design sa drift. Kasi nga, ang laki ng displacement. Okay? While yung mga low-rise building, ang laki nung kanilang peak acceleration. Halos sumasabay sila, no, dun sa high frequency ground motion, yung mismong PGA, no, okay? And that's why meron ditong picture also ng ating code-based response spectra. Kita niyo, no? Ito yung basically, no, if you smoothen this response spectra, ganyan siya. Yan, kagaya ng response spectra natin, ng code-based response spectra natin. Okay? And then so another rule of thumb, no, another approximation, no? That's why, no, when you're designing a low-rise building, no, most likely, no, that the governing base shear formula is this. This is your Vmax. Kasi makita nyo sa formula, this is, yan, as andyan yung peak. No? Kasi yung mga low-rise building have a tendency, no, na mag-resonate dun sa high frequency vibration. Okay? Then yung mga high-rise building, ang tendency, dito sila mag-govern. No? So, okay? So this, itong area na to for low-rise building. While this one for mid-rise to high-rise. So papasin niyo, no, pag 2-story, 3-story, madalas ito mag-govern. Okay? Okay, so this is a ayun nga, no, a sample code-based response spectra. So input nyo lang kung anong zone ka, ano yung distance mo from the fault line, ano yung soil type ng site mo, and then mag-generate yung NA&B, and so the CACB, so makakakuha ka na ng response spectra like this. Okay? And what do you notice? No? Tingnan nyo yung coordinates ng response spectra na to. And this is also about 1.1 G. Okay? Diba? Halos the same nung ginawa natin sa El Centro. No, kasi yung El Centro, 0.3 G na eh. No? Halos 0.4 na rin yun. Eh, no? And by the way, no, I'll show you ito. Yeah. So SeismoSignal. Ito. Where is that? Acceleration. So ngayon, graph. Ito to. Period versus acceleration. Ayan. Ayan na lang. Ayan. Halos, yan. Ganyan na. Ayan. 1.1. Ito yung maganda sa software na to. No? Automatic. No? Mag-import ka lang ng, ng ground motion. Automatic. Mag-generate na niya yung response. Okay? Pero syempre, sa mga students ko, sa masters, no, pinapagawan ko sila ng spreadsheet. Para alam natin, no, ano yung algorithm ng mga software na to. Okay? Okay, so it's your response spectra. And that's 1.1 G. No? That's too large. No? And ang ginagawa natin sa code is, balikan natin itong formula na to. No? So makikita nyo, this is 2.5 CA. 1.1 G. Now remember, your V is, let's say, stick tayo dun sa 2.5 CA W over R. Yan. So, this 2.5 CA, ito siya. Yan. Okay? But, syempre, yung gagamitin natin sa design, no, is less than that. No? And nangyari yon because nag-incorporate tayo ng R value. No? So, If you convert that, that's roughly, ano, hanggang dito lang yan. Sabi natin hanggang dito na siguro. Yan. So, ibig sabihin, yung magnitude na to, yung reduction na yan is due to the R value. Doon papasok yung R equals 8.5 for SMRF under zone 4. Okay? Yeah. So another reason bakit kailangan natin maging knowledgeable sa response spectrum or the spectral acceleration na tinatawag is because nag-release na, for example, si PVOLTS ng SAM-PH, or the Spectral Acceleration Map of the Philippines. And this, if you now know how to generate a response spectra by use of numerical methods, or SeismoSignal, at least may idea kayo, what's a spectral acceleration. For example, this is a map in Valenzuela, yan, So ito, sinasabi dito, meron kang spectral acceleration for 0.2 seconds structure. So ano yan? That's about 2-story. Ibig sabihin, kung may 2-story sa site na to, and nag-occur yung MCE level earthquake, pag sinabi kasi MCE yan, 2475, yan yung return period, to give context, di ba kanina, yung DBE natin, sabi ko kanina, has a return period of roughly 500 years or 475 to be exact. Yung MCE, ito, return period is 2475. So sobrang laki. Sobrang laki. Now, let's say Valenzuela. So, may kita nyo sa contour map, that's 1.2. 1.2G. Sabihin, meron kang 0.2 second structure na period. To visualize, that's about 2-story. Sinubject sa MCE level earthquake na pwedeng mag-occur, around Valenzuela, na nasa rock site, so it can experience a 1.2G spectral acceleration. So, ganun kataas. 1.2. Kasi kailangan yan sa IBC format. Well, it's not official yet, but once na may ganito kang data, spectral acceleration mo, pwede ka nang mag-employ ng IBC format na base shear. Okay. So you also need the spectral acceleration ng 1 second. Naalala nyo kanina, sa 0.5 seconds or 5-story, ano yung spectral acceleration sa El Centro? 1.1G. Yeah? So ito naman, 1 second. Ano yung spectral acceleration? Sa MCE level, Valenzuela, roughly 0.5. Sabihin, 10-story. Siyempre, mas mababa na yung kanyang spectral acceleration kasi mas flexible na siya. Okay? So 0.5G na lang siya. Okay? And that's why meron akong snippet dito ng IBC format kasi in case lang naman na we transition to IBC, yun yung input natin. I-input niyan, yung 1.5 saka yun nga, yung 0.5G na spectral acceleration. Yan. And then pag na-input mo na yun, SS, yun nga, 1.2 tapos S1 na 0.5. Next na kukunin mo is yung FAFV. FAFV. So kung nasa soil type D ka, or site class D, your FA is 1 and FV is 1.5. Okay? Well, pakita ko lang saglit. That ayan, ASCE 710. Ayan. So ito yun, ito yung sinasabi natin. Mag-i-input ka ng FA And I mean, if you input your soil type, no, makukuha mo na yung FAFP, yan yung pang-amplify, no? Kasi sabi nga natin kanina, di ba? Yung MCE na yan, nasa location ka ng rock. Di ba? When earthquake happens, sa bedrock yan. No? So basically, kung ano yung nangyari sa bedrock, yun din mararamdaman mo. No? Sa bedrock, no? Pag nangyari earthquake, no? However, di ba, generally, sa Metro Manila, no, we're sitting on top of a bedrock. Meron kang soft soil. Meron kang soft soil sa ibabaw. So, when this 1.2G acceleration happens here, ma-amplify pa yan further. And yung amplification na yun is due to these site coefficients, FA, FB. Okay? And ito na yung result. Yan. So you will see na amplify siya, naging 1.5 and 0.9. Ulitin ko, 1.2, 0.5 for example. Yan. Amplify siya, 1.22, and then yung 0.5 naging 0.75G. Okay? Now, however, MCE level yan. No? Di ba nga, sabi natin kanina, yung return period na di-design natin, about 500 years. Eh yung pre-provide ng SAM-PH, 2,500. So, convert natin yon into DBE level. Ito na siya. Yeah. So, naging 0.81 na lang, 0.5. Using this formula. 2/3 lang naman. No? 2/3 lang yung multiplier. So, that's it. No? So, basically, yun lang yung kukunin natin. No? That's the use of spectral acceleration. No? Yun na yung IBC format. No? You need to be aware of the spectral acceleration. Okay? Ayan. So, next is, so, go into detail na tayo sa response spectrum analysis naman. No? What's the meaning of response spectrum? So, the ground motion representation should be in accordance with section 208.5. Okay. And nabanggit dito, no, the number of modes. Siyempre, madalas naman ang i-response spectrum natin, multi-degree of freedom. Diba? Hindi naman single degree of freedom na building. Okay? So, ano sabi sa number of modes? No? May be satisfied by demonstrating that the modes considered at least 90% of the participating mass of the structure. So, ibig sabihin, we need to get the modal period, the modal mass, and the participating factor. Okay? So, ano lang tayo, sa mathematics lang, no? So, as a demonstration, no, let's say we have a 5-story building here, no? Plain frame lang na model, no? Just to show, no? So, from the equation of motion na yan, plus KU equals 0. Yan. So this is a free vibration, MDOF equation. Yan. So we can convert this formula into K minus omega square M. Yeah. Sabihin, this is an eigenvalue problem. So maghahanap tayo ng value ng omega square or say lambda, no? With a given stiffness and mass. Given yung stiffness and mass, maghahanap tayo ng value ng lambda to make the determinant 0. Okay? So, as an example here, no, ito yung formula nung nung ating mass matrix. So, yan, makikita nyo, kailangan mo ng mass matrix and then kailangan mo din ng stiffness matrix. Okay? So, diagonal naman yung mass matrix natin. Yan. And then ito naman yung formula ng ating stiffness matrix. So, basically, may pattern naman. No? Nakikita nyo, no? K1 plus K2, K2 plus K3, yung second floor, third floor and fourth floor and fifth floor, and then yung fifth floor yung dulo. Yan. Yung M mass matrix, madali lang. Diagonal lang yan. M11, M22, M33. So basically, you can lump the masses, no, per floor. Okay? So when you do that, Yan. So, merong numerical methods approach ulit dyan, no, to get the eigenvalue. No? So, for example, ito yung hindi ko ma-zoom in. Yan, no? So, ito na yung nakuha ko, no? Nag-employ na ako ng numerical methods to find the modal periods. Yan. Ito yung modal periods mo. And then, ito naman yung corresponding eigenvector. Yan. So, eigenvector, this is 0.6. Ito yun. 0.55, 0.46, 0.33, and then 0.70. So when you connect the dots, ito na siya. For mode 2, ito naman yung eigenvector. Negative 0.55, so negative nasa left side. Negative 0.70 nasa left side pa rin. 0.33 nasa right side. 0.6 nasa right side. 0.46 nasa right side, and connect the dots, that's your mode 2. And then mode 3, negative 0.46, positive 0.33, 0.55, negative 0.17, negative 0.6. Connect the dots, that's your mode 3. Yan. And then yung corresponding periods ay ito. 2 seconds, 0.68, 0.43, 0.32, 0.285. Okay? Yeah. Actually, ito siya. Ito yung staad niya. Ito natin, just to give you an idea. Okay. Yan. So parang pinakita ko kanina, no, sa single story frame, no? So sa loading, maglalagay ka ng mga masses. Yung mga mass mo, for example, 444 kilonewton per floor. Yan. So i-excite mo siya sa x direction. Yan. Kasi nga, yung vibration natin, lateral, no? On the x direction. No? Tapos, yan, you will use this command, modal calculation. Okay? And then run it, no? And then when you run it, post-processing, okay, dynamics. Yeah. So ito na yung corresponding period. You have mode 1, 2 seconds. Okay, view. Yeah. 2 seconds. Itsura ng mode 1, no? And mode 2, results. So mode 2. Yan, pag ganon, no? Yeah. And ito naman mode 3. And mode 3. And then mode 4. Yeah. And mode 5. No? Okay. So next. Ito ko lang, no? So, let's say, alam na natin yung mode and mode shape, no? So, generally, pag given yung stiffness, given yung mass, alam mo yung mass and stiffness ng building mo, no? You can get the frequency and the corresponding mode shape. Okay? And then, how to get the mass participation? Ito na yung, dito mo malalaman how significant yung mode. No? Kasi nakita nyo sa definition, di ba? Nare-require ni code at least 90% of the mass mag-participate. Okay, so ito yung mathematics, no? So the formula is basically L, itong L na to is M times V, the eigenvector. No? Yung mass, tapos yung corresponding, for example, L1, yung diba? Ito yung, this is 5-story, di ba? Yan. So your L1 is equal to M11 phi 111, no? Tapos plus M22 phi 12, M33 phi, yung 1 meaning from mode 1. No, yun ibig sabihin nun. Ito. Itong another one, yan yung mass eigenvector, di ba? Ito yung eigenvector natin. Yan yung coordinates. So let's say this is M11. So ano yung value ng eigenvector dito sa location na yan? Okay? Due to mode 1. Yun lang yun. No? And then may formula. Then for this value M, basically, same formula, no? Except naka-square lang. No? Naka-square lang siya. Okay? Kita nyo naman, no? Then, pag nakuha mo na yung L and M, no? Next is you need to find the modal weight. No? Ito naman yung formula. Kita nyo, no? L square over M. Itong G naman, constant yan. Eh, no? English units, 386.4. Kung SI ka, 9.81. No? So yan, makukuha mo na yung modal weight. And then, basically, divide mo lang by the total weight per modal weight. No? Kaya papansin nyo, ito, ibig sabihin, si mode 1, no, 440 kips yung na-occupy niya. Eh, yung total weight natin is 500 kips. Okay? So, 440 divided by 500, you will get 88%. Okay? Then, si mode 2, na-occupy niya is 44 kips, no? And then, divide by the total weight, 500, so that's roughly 9%. Okay? So this shows that si mode 1 has the most significant contribution. No? Yung mass participation niya is 88%. Okay? That's why, ito yung concept sa static analysis. No? That's why yung mga low-rise building natin, no, nakita nyo yung definition kanina, inaalaw ang static analysis because the mode 1 generally prevails, no, is dominant for low-rise building. Yeah. Ibang storya na pag high-rise na. Habang tumataas yan, no, may kita nyo, itong higher modes, no, shoot up na yung value niyan. Kasi nga, nagiging flexible na yung structure mo. Eh. No? Okay? Okay? Unlike kanina, no? yung kanina, yung one-story frame kanina, nakita nyo, 100% pa nga yung mode 1 doon. Eh. No? Ito, nung 5-story na, pansin nyo, bumaba na yung mass participation niya. Okay? Dito sa Staad, 87%, 86% na lang. Okay? Tapos si mode 2 is now 10%. So, if susundin natin si code, kailangan nating mag-gather or i-capture both mode 1 and mode 2 to get the total response. Okay? Kasi nga, the code requires us to obtain 90%, you know, at least 90% of the mass of the structure. Okay? So, simple lang yan, no? Ng mass participation. So, yan yung ano talaga yan, computation yan, no, sa lecture. Okay. So, yun yung modal, multi-degree of freedom. No? But, I'd like to discuss shortly modal orthogonality. No? Let me have a, 10 seconds break lang po.
Okay, so yeah, so I can make announcement, no? Okay. Yeah, so nasa FB Live, no? So while Sir Paulo on break by 1 to 2 minutes, no? Yeah, so we're on Facebook Live, no? And also merong registration link dyan, no? So you need to fill out, no? So double check the attendance, no? And Yeah, may mga questions coming. Mamaya natin i-tackle at the end of the seminar, no. Doon natin siya magkakaroon tayo ng discussion, no, after the webinar. Then yes, yung prices, yes, okay. Naka-ready na yung ating ruleta, no. Okay, for the price. May link provided, I believe, na-send si technical support. Okay, nandito, no, para dun sa registration. Okay, so but I can send it here again, no? Yan. Okay. Okay, so that's it. So, well, okay, Sir Paulo na po ulit.
Okay, so let's resume, no? Modal orthogonality, no? Ito, this concept, no, allows us to combine the responses of each mode, no? Kasi, di ba, galing tayo sa SDOF, single degree of freedom problem, no? Diba, ito single degree of freedom problem. Ngayon, we're dealing with multi-degree of freedom. Ganyan na siya. Okay. So, this modal orthogonality, no, shows that the total response, no, of our multi-degree of freedom problem is the combination, no, of the modal responses of each mode. No, diba? 5-story tayo kanina, no? Gawin ko na itong 5-story para consistent. 1, 2, 3, 4, 5. No? So, meron tayong mode 1, meron tayong mode 2, meron tayong mode 3, 1, 2, and mode 4, so on and so forth. No? So, ganyan yung itsura. Okay? Yan. So, this concept, no, will show that kukunin natin yung response of our mode 1, i-add natin sa response ni mode 2, and then sa response ni mode 3, so on and so forth. Okay, so first, no, the response is the formula of the response is this, no? Q is equal to phi Q. Itong phi, basically, yan yung eigenvector natin, no? Q, yan yung tinatawag na response of your single degree of freedom. So, kaya yung discussion ng dynamics, kailangan required talaga mag-SDOF ka muna. Kasi hindi mo maintindihan si MDOF or hindi mo solve si MDOF pag wala kang prior knowledge ng SDOF. Okay? Okay. Now, so ito yung ito yung flow ng nung formula for this. Yeah. Diba? Let's say kasi sa differential equation, no, you assume a solution like this, no? Tapos substitute mo, no, the equation of motion, and when you substitute that, ito yung lalabas. Okay? Kita niyo ba? I-zoom in ko. Yeah. Okay. Yan, ito yung lalabas, no? But remember, no, this is your Q sub n, no? Q sub n. It should not be 0, no? Kasi nga yan yung assumed solution mo. Therefore, this term here, no, is 0. Kaya inequate natin siya into this. Okay? Okay? So K phi n is equal to omega square M phi n. Okay? Yeah. And then, so sabi dito, okay, so i-multiply natin both sides by phi transpose. Yan, phi r transpose, yan, lagyan ng yan, okay? And then also the other phi n transpose naman. Ano? So it turns out that in transpose, and then sabi dito, no, transpose matrix on the left side will equal the transpose of the matrix on the right side of the equation. Tapos, pag sinubstitute natin siya, yan, papansin nyo, no, equal to, di ba? Phi and transpose MPR. So, nag-appear siya, right? So, and then substitute natin, naging ganito. So, what does it mean? It means, no, either omega n square minus omega r square is equal to 0 or phi n transpose m phi r equal to 0. So, isa lang doon pwede mag-0. Now, nakita nyo, no, nag-staad tayo kanina. No? Napapansin nyo naman, equal ba ang mga frequency? Di ba? Hindi. Therefore, itong omega n square minus omega r square is not 0. See? No? It's because in general, no, hindi mag-equal sa 0 tong term na to. Therefore, this term, phi n transpose m phi r is equal to 0. Okay? Phi n transpose m phi r is equal to 0. So, ano ibig sabihin nun? Phi n transpose m phi r is equal to 0. Yan. Dahil, pansinin nyo, yung subscript natin n, tapos yung subscript nito r. Magkaibang mode yan. Ibig sabihin, pag sinulat natin yung eigenvector ni mode 1, transpose, m, phi, tapos mode 2, that will be equal to 0. Hindi pwedeng mangyari yun. Yan. Okay? Kailangan magkapareha sila. Phi 1 transpose, m phi 1 may value. Otherwise, magsi-0 yun. Yan yung modal orthogonality. Yan. So, kung i-apply natin yan sa equation of motion, yan, mu double dot plus cu, kasi nyo, no, lagi tayong bumabalik sa equation of motion, no, plus ku equals force, no, yan, substitute natin yung displacement formula, phi q, yan, m phi q double dot, kasi di ba, remember, this is u double dot, u dot, and this is u, no, phi q, okay, yan, and then, lagyan natin ng phi transpose both sides, no? Magkakaroon tayo nito. Okay? Next. Now, knowing that, di ba? Phi, di ba? Balikan natin, ha? Phi transpose m phi. Sulat ko, di ba? Phi transpose m phi. Knowing that hindi po pwedeng mag-combine yung magkaibang subscript, no? Tapos with P1 transpose M P1. When you do that, magiging diagonal matrix to. Ito. Ibig sabihin, when you operate this, magiging ganyan, diagonal matrix. So, ganoon din sa damping, and then sa stiffness. Pag then expand mo yan, you will get this. So, mapapansin nyo, lahat sila naka-1. So, ganun din sa M22, C22. So, this is now what we call an uncoupled equation. Ibig sabihin, independent na yung bawat mode natin. No? You can now analyze for mode 1, for mode 2, for mode 3. Q1 is the response ng mode 1. Q2 is the response ng mode 2, so on and so forth. Yan. So, yung coupled equation natin, na-uncouple natin because of the modal orthogonality. Okay? And so divide the equation by mass, you get this. So parang nakikita nyo, no, similar dun sa equation natin kanina, u double dot plus tuc omega, u dot plus omega square u. Same nung equation natin kanina. Kasi nga, naka-Q lang because this is per mode, no? Response per mode, equation per mode. Okay? And then you will see, and so simplifying, no, you will see you have a term this. Ito nga yung tinatawag nating mass participation factor or the modal participation factor. Okay, which is yun yung ginawa natin na kanina. No, yung kinuha natin kanina. Okay? Okay, so mag-response spectra analysis na tayo. For displacement lang ha, for displacement lang. Kasi yung 3D, kay Sir JP yun. No? So, application lang for displacement. So, i-subject ko ngayon itong aking 5-story building sa El Centro ground motion. Subject ko siya. So, again, punta kayo sa loading. And yung ano, no? Ito yung acceleration, ito yung earthquake, ground motion. Yan. So kanina, yung single frame lang yung sinubject ko sa El Centro. Ngayon, 5-story frame. No? Isasubject natin sa El Centro. Then let's compare the response. No? So, ayan. So I think na-analyze ko na to. Post-processing. Punta ako sa displacement. Ay, bakit? Di pa yata na-analyze pala. Loading, analysis, run analysis. Okay, apply sa post-processing. This layout. Bakit wala yung displacement? Open here. Teka. Wait lang, lalagay ko muna yung yung time history natin. So, add time history, ground motion, direction of course, X, arrival time, yung acceleration, na-detect niya kasi naglagay nga ako ng center ground motion, and then add, yes, close. Yan, nalagay ko na siya, and then analyze. Analysis, run analysis. Okay, done. Post-processing. Tayo sa displacements. So, balikan natin yung balikan natin yung concept natin kanina, no? Ang mode 1 natin ngayon, 2 seconds. No? Sabi ko nga sa approximation, 20 story. No? Pero ito, it turns out 2 seconds mode 1 natin. Ano yung peak response sa mode 1 kanina? Balikan natin. Associate. Kasi naghihingi si Staad ng group name. Ayan. So yan. So yan na yung peak response or time history response. Ito na yung time history analysis ng ating 5-story. Yung kanyang peak response is 176 mm. 176, that's about 7, 6, no? Or 7 inches, no? 7 inch. No? Kung babalikan natin yung ating 2 seconds. 2 seconds, mode 1, no? Mode 1 has a peak response of 5.38 inch. 5.38 inch. Ito na yung tripartite curve, no? Kumbaga pinagsama-sama yung displacement, acceleration, saka velocity response spectra. Okay? So ito yung kinaganda ng response spectra, no? Mabilisang analysis. Kasi 'di ba yung naka-umbrella sa dynamic analysis, response spectra saka time history. No? Siyempre, nung na-develop yung code, no, hindi naman matataas yung specs ng mga computers, no? The engineers, no, should devise a way ng mabilisang procedure to estimate, no? In the case of displacement, for example, no, ito nga response spectra. No, because kapag may data ka na ng response spectra ng a certain earthquake, for example, for each SDOF, mabilis mo nang pipick mo na lang 'yon, no? Pipick mo na lang 'yon. So for example, so mode 1 nga natin, no? For 2-second structure, ang nakuha natin 5.38 inch. Okay? For mode 2, 0.7 seconds, ang peak response natin is ito, 2.583 inch. Okay? Okay? For mode 3, ayan, 1.5. Pinapakita ko lang yung snapshot ng spreadsheet para makita nyo na nakaka-capture nga natin siya, no? For mode 4, 0.34, ito din yun. Where's that? And then for mode 5, 0.3 seconds, ang peak natin is 0.67 inch. Ayan. So tandaan nyo yung values na yan, ha? So each mode, no? Kumbaga, nag-SDOF analysis tayo, no? Kung kinuha natin yung modal period, no? Tapos kinapture natin yung peak responses, no? 5.3, 2.5, 1.5, yan. Ayan. Ilalatag natin siya dyan. Ayan. So, kanina, we use this formula. Ngayon, dahil nga na-involve na sa equation yung participating factor, ito na siya, gamma. No? And then phi, etong D na yan, yan yung basically the response of the SDOF. Yeah. Okay? So ito yung gamma natin using this formula. Yeah. Then ito naman yung ating D. Ito yung gamma. So the phi vector, ito. Yeah. Meron kang gamma, meron kang phi, meron kang D from the SDOF responses, makukuha mo na yung corresponding displacement. So, next page, ito na siya. Si mode 2, ito na yung response ni mode 3, ni mode 4, ni mode 5. And then, using SRSS, yan, di ba? Sum, the square root of the sum of the square. Square root of the sum of the square. Yeah. And using RSA, you get 6.85. Now, without using Staad, nakuha natin yung displacement using response spectra analysis. Basta't alam mo yung basta't alam mo yung modal period mo. Okay? We get this displacement, 6.85. Compared, no, kung funds, we get 176. Okay? So 177 inch. 6.93 inch. Okay, versus sa 6.85. Kita nyo, no, medyo dikit, no? And actually ito na yung table of comparison ng CHOP. No, using RHA or yung time history na ginawa natin, no, 6.85, using SRSS 6.8. Okay? So that's it, no? That's the comparison of a time history analysis versus a response spectra, no, for determining displacements. Okay? So last, no? Quick ko lang, no, because Sir JP will do the actual demo, no? So let's say may 3-story ka, no? Yan, sabi ko nga, no, kukunin mo lang yung code-based response spectra, code-based na to, no? Kanina, actual earthquake ground motion ginamit ko. Ito, then import mo sa Staad, no? And then you get the, syempre, you apply in both direction, X and Z, no? And then yan, magpe-prepare ka ng masses acting in X and Z direction. Tapos lalagay ka ng additional load case, no? X and Z. Yan. I just want you to emphasize this, no? Laging question kasi ito, no? Ito kasi yung instruction sa Staad, no? Pagsasamahin mo na yung mga masses. Yan. Ito yung, this is the mass for X, this is the mass for Z. Tapos ito na yung response spectra from our spreadsheet. Yan. Hindi mo na uulitin itong mass dito. Mag-e-error. No? Mag-e-error yung. Yan. In my case, no, nag-e-error siya. And then, papalitan mo lahat ng mga static load case ng ng, di ba, 8 and 9, no? Papalitan mo siya ng mga dynamic load case. Kasi nga para yun yung gamitin for design, no? Then sabi sa code, no, you need to compare, no, the static base shear, no, with the dynamic base shear. Base shear, design base shear. Kapag regular structure ka, at least 90% pwede, no? So kumbaga, kung mas malaki si static than dynamic, no? Tapos regular naman yung structure mo, no? Pwede mong scale up to 90%. Parang reward sa Unicode yan dahil gumamit ka ng mas exact method than static, no? Pero kapag irregular yung structure mo, no? Ang sabi ni code, kailangan 100% equal yung static sa dynamic base shear. Okay, so in this case, at the first run, for example, ang nakuha ko is 5.2, while yung static ko is 5.9. So, malayo, no? May mas maliit pa, no? Mas maliit. Then, to match up dun sa static base shear, kunin mo yung scale factor. In this case, 1.13, for Z, 1.14. Yan. No? Then, rerun again, no? Yan, makikita nyo, halos tugma na sila. 5.9, 5.9. Okay? And then, that's it. Iyan mo siya. Import mo na sa RCDs. So, thank you for listening. Sakto 3,
Okay. Anyway, bonus na rin, no? Bonus hours to to the end user. Okay, so thanks Sir Pao, no? Paulo, for delivering the highly technical, no, like discussion regarding responsive spectrum. So what I'm gonna be doing now is yung Staad applications na, no? So kung paano yung gagawin. So I'm gonna be sharing my screen. Okay. Move ko lang tong aking, yan. Okay. Actually, I have 3 models here, no? And also, I'm gonna be discussing yung mas madaling way, no? So, which is a new feature with the latest Staad Pro, like release, no? Sa paggawa ng seismic mass, no? Let me open. Okay. Anyway, this is the final model, no? Pakita ko lang sa inyo yung final model. So 5-story structure, so my shear wall, and then primary load cases, then may responsive spectrum load here, no? Okay, so which is yan, so bale nag-paste lang ako dito ng period acceleration pair, no, from my Excel like RS curve builder, no? So galing dito yan. So whenever I change something here, no, let's say automatically nag-change yung mga values dito, and then as easy as like copying and paste itong mga values na to dito kay Staad Pro, no? Okay, so ito kasi final na, may scale na, no? May scale factor na, pero we're gonna discuss kung paano nag-arrive with this scale factor, no? So let me just open yung initial model, which is this one, move ko lang with my dual monitor, no? Okay. Okay, so maybe doon sa iba naming trainings, no? Sa iba naming trainings, we're using reference load, no? So dinidefine namin yung dead load and live load here on reference load. No? So tapos i-call out siya dito, no? I-call out siya dito. Pero with the mass model generator, no? Itong mass model generator, so kung meron ka ng mga load items under the load cases details, no? So wala akong reference load dito. Okay, dead load, live load, dead load, two dead loads, no? And then the live loads, no? So parang baligtad, no? So yung mass from these load cases mapupunta doon, no? So using the mass model generator, which is this one, no? Ito yung gagawin ko ngayon. So kasi kailangan natin ng seismic mass function, no, for ELF, no, static seismic and dynamic, no, seismic, no. So when I click this mass model generator, so pag click ko nito, okay, so lalabas tong dialog box na to, and then by default ito yung mga values, no, so naka 0.5 si live load. Ngayon depende sa discretion nyo, no, kung if you will gonna include the live load, no, but for the purpose of this like webinar, no, maglalagay ako ng 25% live load sa seismic mass, no. So 100% dead load and 25% live load, no. So notice here kung anong mangyayari dito sa reference load, no, when I click this generate. So pag click ko ng generate, ayun, okay. So that's it. So as simple as that, no, from that like one direction dead load, no, and live load, so magge-generate ng seismic mass ng 3 direction yung program, no. So kumbaga mas ngayon mas madali ngayon mag-generate ng seismic mass, no. So from load items, then diretso ka ng seismic mass. Ito yung ginamit ko sa project na to, no. So now okay, so gamitin ko tong isang model, so which is this one, no. So sa Bayesian scaling, so okay, so meron na akong seismic mass here, no, and ready to analyze na to, no. So I'll just go here on analysis and design and then click run analysis. Wait a second, save. So andito. Okay, so, and mga scale factor dito, ano, kumbaga wala pa, no. Yan. So dapat pala hindi ko muna ni-run. Okay, so click muna ako ng done. So balik muna ako sa loading, and then punta ako sa may yung response spectrum load natin, no. So edit ko lang to. Edit, no, naka 1. Okay. So ang initial value mo dito would be the I over R, no, importance factor, divide by the R factor, no. So ang initial scale natin diyan 1 divide 8.5, no. So 8.5 for special moment dual system o kaya ang special moment frame. So bali ito yung initial input natin dito, ira-round off ko yung dulo, no. So which is 5, no. And then click ko to modify, then click yes. Then ganun din sa other direction, the Z direction, no. So click ko to edit. Okay. And the Z, and paste ko dito, naka-round off yung dulo. Ayan. Okay. And then click modify and then click close. Then i-review lang natin yung seismic parameters natin dito, no. So click edit. And so ito yung ating mga seismic parameters. 0.4 importance factor 1, no. Then the R values, soil profile type, the NA and NB, then the city. Then mamaya itong period, ipo-force natin yung values dito, no, from our like modal analysis, no. Okay, so which is ito yung gagamitin nating period sa pang-scale ng Bayesian, but also for the drip check as well, no. Ayan. So i-close ko muna to, and then I'm gonna run the analysis. No, run analysis. Then just click save. Okay. And okay, then just click done, no? And then reviewin natin yung period ng structure, click apply, no? And we'll go here on dynamics, no? Ayan, so you can also review the mode shape here, no? Mode 1, mode 2, mode 3, no? So, ayan. So hindi naman siya torsional sa mode 1, no? So which we are avoiding, no? So going X yung yung like dominant sa X, no? Yung first mode shape, no? So which is ayun, along X. Then second mode on Z, no? And then nasa other modes pa yung torsional mode, no? So yung mga succeeding modes. Then I'll go here sa ito, kunin natin tong period, no? So which is 0.639 and 542, no? So kunin ko lang 'yan, which is 0.639 and 0.542, no? So bali nawala. Okay, so itong 0.639 tsaka itong 0.542, no? So ngayon, babalik ako dito sa model, so analytical model, and then balik ako sa loading and edit ko to. Okay, and 0.639, no, sa going X direction, and then 0.542 dito, no? So sa yung second mode, no, sa going Z. Then modify ko to. Okay, click yes and then close, and i-run ko yung analysis, no? So run analysis uli. Okay, and then just click save. Sana ayun, eto. Okay, then i-review natin yung base shear from ELF, no? So view output file, click done. Okay, and okay, so ito yung static base shear natin, no? So on the X direction, pinorse natin yung structure to have this period, no? 639, and then other direction, ilang ba value natin dito? So 3919. So let me check kung nandito sa aking Excel, no? Yan, so which is this one. Okay? Yeah, so 319, no? 0.19, no? Then sa other direction, so I think similar din, eh, no? So because of yung formula kasi, no, ito na yung parang maximum base shear, no, na makukuha mo, no, which is 3919, no, 0.19. So same. Okay, so then itatabulate ko siya dito, no? So base shear static, and then we're gonna scale, we're gonna use 90%, no, of this base shear. So 90% ng static base shear, which is this one. Then kunin natin yung base dynamic base shear, which is this one. Okay, so galing din sa output. Pupuntahan natin yung Modal base action sa X direction, so which is 3159.18, so which is this one. Okay, so ginamitan natin CQC method. Okay, 3159.18 X direction, and then Modal base action naman on the other direction, X ito, And then, so 2735 naman, ano, 2735 sa Z direction, no? So, which is this one, okay? Then, i-divide natin, no, itong 90% ng static base shear into the dynamic base shear. Okay, so which is 1.11. Kaya lang, may initial scale na tayo na ginamit, no? So which is the I over R, no? Kaya lang 1.0 yung ating importance factor, dinivide natin sa 8.5, no? So which is ito. And then the final scale factor na gagamitin natin, no? For the dynamic seismic load natin is itong values na to, no? So very easy. So you just, kung nakatabulate yan sa Excel, so kopyahin mo lang ito. Then magra-run ulit pa tayo ng isa pang analysis, no, with the final scale factor. Balik tayo dito sa loading, and then sa RSA natin, which is this one. Okay, so click edit, then so paste ko dito, no. Okay, so modify, click yes, and then click close, and kunin ko tong scale factor na to. Then sa other direction tayo, which is this one, edit, then paste natin dito. Okay, then click modify, and then click close, and then run na natin yung ating final analysis, no? Tingnan natin kung magma-match ba siya sa 90% static base shear. Okay, so click save. Okay, so dapat yung dynamic base shear natin ay mag-equal sa ito, no? Itong dapat maging ganito, isang 3159 tsaka isang 2735, no? Sa C direction, X direction, and then Z direction. So, I'll gonna click done. Okay, then balikan ko yung ating model, okay, which is this one, utilities, and then analysis output. Then balik tayo sa modal based action. Okay, so ayan, so 3527, no, yung ating 90% static base shear. Yeah, which is sorry, ito pala, no, sorry, 35. This is the 90%, not this one. 90% is 3527 2.19, no? So which is ayun, so eksakto. And then on the other direction, so wait a second. Yeah, should be 3527 din, no? So sorry. Nasaan yung aking Excel? Okay. Excel, wala. Excel, yeah. So this should be actually both, no, both X and Z direction. So we should have this same value, no, 3527 then yeah, which is ito, no. Ayun, and then few discussion, no. So after this like the demo, no, and response on base shear scaling, no. So may inad ako na command dito sa sa model, which is may torsional irregularity checks, no, so which is the program is able to perform, no. So and bibigyan kanya ng notification kung okay or not okay, no. So kaya lang before this webinar kasi na design na tong structure na to, no. So kaya ayan, okay naman siya with torsional irregularity check, no. It says okay, no, and checks ng reentrant corners, then mass irregularity check, no. Okay, and also I have added here drip check as well, no. Okay, may calculation tayo sa allowable elastic drip, then i-compare mo yeah, with the actual, but the program is able to perform that automatically, no, by putting the allowable drift, no. And then yun, so mag-output siya kung pass or fail, no. And then also soft story check, no. This structure is okay. Yes po, yeah. So i-share yung model. Yes, yeah. Yeah, okay po. I-share namin yung final Staad model. Yan, yeah, that's it. Okay, so with that, no, so as easy as that, so yeah, so that's how you perform yung like response spectrum analysis, and then load combo, no. Punta ko lang ito, may load combination na ba to? And yeah, so you're gonna replace yung static earthquake load, no, ng dynamic, no, so with that similar load combo. And then if you want to design kung ano yan, kung concrete or steel yan, no, so kung concrete RCDC, sa steel naman diretso na kay Staad Pro. Okay, so with that, yeah, that's for my application nung response spectrum analysis with Staad Pro. Okay, so yeah, so with that, so we're gonna have like a maybe 5 to 10 questions, no, then question and answer. Then after that, we're gonna be doing the raffle, no, live din dito, no. So thank you sa mga nag-share. And in like to compensate, no, yung like pag-share nung this webinar, so like 10 winners will gonna win, no, like yeah, 1,000 GCash po, ano. Ayan. So may question dito, no, ideal number of modes, yeah. So story times 3, no? Kaya ang ginamit ko kasi dito sa sa model na to ay I believe 18, no? So modes, control F, control F mode. Yeah, so I use 18 here, no? 18 number of modes. So 6 kasi almost 6 story, no, with the 5 story plus yung in-add ko yung like yung small structure pa, no, above the roof. So kaya nilagyan ko ng 18. But when you review naman the output here, no, nag 90% naman siya, participation factor. Dito tayo sa my model based actions, ito participation factor, no, so nag 90% pa siya sa mode 4 pa lang, no. So mode 4. Yeah. Okay. Recorded session po ba? Yes. Actually sa FB Live meron na, no. Nandun na yon, plus we're gonna upload sa YouTube din po after. In case of horizontal irregularities, the centricity is manually modify. Yes, may input. Yeah, may meron din dito eh. So edit, no. Then you can edit from here. So pwede mong kontrolin dito yung eccentricity, no, values. Though, but mas mataas yung ginamit na PGA sa bridge, no? Sir Pao, I think Sir Pao can answer better here. Yeah, ayun. Na-answer na ni Sir Pao, no? Because
Yes,
we're
yes,
bridges design elastic.
more on elastic response kasi yung nire-require natin sa bridge. Unlike sa building, ductile response talaga. Yun sa response spectra, nakita nyo, di ba, let's say 1.1 G, no? Then ni-reduce natin yung base shear natin by introducing the R value. No? So sa bridge, no, mas maliit yung R value niya. So that yung base shear natin mas malaki. Kasi yung R value natin nasa denominator.
Okay. Orthogonal effect plus response spectrum ba yung magiging load combo? Yes, itong ano, ito, yeah, may orthogonal effects to. Yes. Dynamic load ito, then orthogonal effects. 100% and 30%. Sa tech support, meron ba tayong question sa FB Live? I think naka 5 answers na tayo. I'm not sure, hindi ako nagbibilang, but I think. Paano nakuha yung safety factor na 1.3 and 1.5? Okay, ulitin ko lang. Bale, yung safety factor ay, yeah, so galing dito, no? So ito ay nakuha natin from static analysis, no? Tapos ito naman from response spectrum na may initial scale na I over R. Then we're gonna use 90% no Bayesian scaling, 90% ng ano ng static no, multiply ito ng 90%, so 3527. And then so you're gonna divide the 90% dynamic Bayesian sa static Bayesian over dynamic Bayesian. Okay, then makakakuha ka ng itong values na to, 1.11 and 1.28. Kaya lang may initial scale na tayo na ano I over R, no? So binaba na natin ng I over R. So then i-multiply mo tong dalawa na to, and then you get this final scale factor, no? So ito yung magiging input mo ngayon dito, no, sa iyong response spectrum load, no? Ayan, so dito. Okay. Bali yung answer doon yon. Yung initial bale ang answer diyan, yeah, so 90% static Bayesian divide the dynamic Bayesian, then multiply by the I over R. Yung accidental torsion effects, ano yan? Pwede mong gawin to pag ano, pag meron yan no, sa ASCE. Pag ASCE ang ginamit mo, I think meron yan. When I click add here, let's say, no. And response spectra, IBC, no. So dito, pwede mong lagyan. Okay. Yeah, pwede kang maglagay dito ng ano ng dynamic eccentricity, no? Then ganun din, no? Gamitan mo ng ano ng IBC, no? So then let's say i-delete mo to, no? And then i-delete mo din to. So delete mo 'yan, then delete mo 'yan, ano? O yeah, then instead na gamitin mo tong mga to, okay, or you can have, let's say, the value here. Yeah, so sa IBC, yes, available yung dynamic eccentricity. Sir, is there any input for zip code in IBC parameters na hindi mag-upload ng acceleration? I-zip code sa US, no? Pag ano kasi, let's say, ang gamit mo ay IBC, i-type mo lang yung zip code, no? Hindi ko alam yung mga values, no? Nung zip code sa US. Pero pag tinype mo dito yung zip code, no, automatic yan nagge-generate yung ano, yung curve dito. Ayan. So I'm not just ready with that, ano, yung kung ano man yung values dito. Then may question here, may option po ba sa Staad na mag-apply ng seismic force amplification factor sa specific? Pag ganito, gawa ka ng special load combo, no? Gawa ka na lang kung gusto mo ng omega factor, omega factor, gawa ka ng special load combo, magdagdag ka lang ng additional load combo, no? And then kung i-design mo yung elements na yun, let's say to RCDC, no? Pwede mong inherit from the Staad Pro yung load combination yun to the RCDC and design your element with that special load combo with the omega factor. Ayan yung question ni name mo ba talaga to? Okay. Ayan. Okay. Yeah, so with that, no, so we're over like time na tayo by 30 minutes. So we're gonna go with the raffle, no? Okay, tech support. So for other questions, no, pwede nyong i-raise, no, sa aming Facebook page, no. Okay, and if you're happy with the webinar po, if you're happy with the webinar, so we would like to ask like a review, no, of our webinar today. Nandiyan yung link. And now we're gonna go with the raffle draw. Okay, ang inaabangan ng lahat. Okay, so which is a GCash GCash winner. Tech support, paki take note ng mga names, no, ira-raffle na natin. And we're gonna check also yung kung nag-share ba kayo, kasi ang mechanics kasi kailangan naka-share siya in public, no? Okay? Naka-share in public. Okay? Yung naka-share in public, no? Yung poster, no? Okay? And thank you sa lahat ng sharers, no? Okay. So now, okay. So tech support, I need help, no? Kasi ira-raffle na natin ngayon, okay? Kasi na-test ko na to eh. Okay, so for all the registrants, as long na nag-register kayo, engineer nyo, no? Then we're gonna check on FB and ayun, kung kayo mananalo. No, sayang din yung 1,000. It's a good pang treat, ano. Okay. So first raffle winner, tech support, I need I need help here, no? Okay? So click ko na to. Okay. Ano? Okay, si Albert Jose Asuncion, no? Okay. Albert Jose Asuncion. Tech support, okay ba siya? Okay. Okay, so then magano pa ako isa pa, susunod ko pa, no? Paki-take note ng name para ayan, take note ng name. Tapos paki-verify ngayon, no? Kung nanalo ba siya. Ayan. Okay. Then next, okay, close. So the next person is so si Jonas Salazar. Feeling ko ako si Kuya Will. Okay. Okay. Paki-screenshot, no? And then ayan, paki-screenshot. Ayun. Bigyan ng jacket. Okay. Okay. Next. Okay. Tayo yata yung bagong Itbulaga eh. No? Okay. Ayun, nanalo si Jonas Salazar. Yeah, okay. So, John Frederick Dison. 5,000. Okay. 1,000 na. Okay. 1,000. Okay. Yeah. Okay. Okay, merong walang nag-share yun, no? Yung meron. So basta mag first 10, no? First 10 na nag-share, okay. Next, no, si So Christian Nickdaw. Okay. Christian Nickdaw. Okay, mas exciting daw to. Okay. Yeah. Okay. So close ko na, no? Ayan, okay. So next. Okay. So Wilfredo Tagab. Okay. Yan. So tech support, paki-guide lang ako kung okay na, no? So ayan. Yes, pandagdag pang-enroll kay kay Xstructures. Yan, okay. Okay, meron na si John Frederick Dison. Okay daw. Yeah, so Libra B Romo. Yan, okay. Okay, so next, no? Okay. Screenshot, tech support. Yan. Okay. So, Carla Manyalak. Okay. Yan. Close ko lang. And yes. Okay. Meron. So, okay. So, click ulit ako. Tech support. Chris Justin Canosa. Okay. Feeling ko nasa noon time show tayo eh. Okay. Okay. Yeah. Okay. Yeah, share nyo pa ngayon. Malay nyo. Anyway, close na ng 1 PM by the way. Okay. So, Chris Justin Canosa. Okay. So, yeah. Paano lang tech support. Okay. Yes, Kuya Will. Okay. Ang bagong Kuya Will ng civil engineering. Okay. Okay, si Mionil Gil Margen. Yan. Okay. Yes, panggasolina raw. O may shoutout pa, no? Okay. Gusto niyo ba ng shoutout? Okay. So close. Ayan. Okay. Okay, so shoutout daw, no? Sir Nico. Okay. So click. Okay. Ayan. Okay, so Philip Jude Divina. Okay. So click close. Tech support, ilan na yung ating ilan na? Yan. Okay. O bigyan daw ng software yan. Okay. Tingnan natin, baka in the future magpa-raffle kami ng software, no? Okay. Sa tingin ko kaya no? So but anyway, titingnan lang natin. Okay. Might be the ZW CAD, no? ZW CAD pwede. Okay, so si Fraser Dominic David. Okay. Yeah, books as well, no? So but at the moment, ayun, may mga next webinar kami, so nabangan nyo lang. Okay. Kung books man yan, so walang problema. A3 printer. Okay. Sige, basta pang engineering. Okay. Laptop pwede, no? Laptop. Okay. So click close. So paki-save lang tech support. Okay. Yan. So click, i-close ko na to. So tech support, ilan na yung ating ilan na yung ating winners. Yan. Okay. Ayun. Thank you, Sir Joseph. Okay. Bigyan na si license yan. Okay. Si license talaga. Okay. Okay. So next is si Mark Martin. Mark Martin. Yeah. Okay. Mark Martin, no? Then that's it. So click lang ako dito. And I think last two na lang, no? Pag yung iba wala pa, we're gonna raffle it internally, no? Internally na lang, no? So with the program, just to end this this webinar. Ayan. So si Shellmark Estrada and one more click. And with that, we're gonna post all the winners, no? Yan, of the yan. Okay. O yung bigyan ng client. Ito matindi, bigyan ng client. Okay. Okay, so last click natin. Okay. So April Joy Bandales. Okay, so with that, yeah, so yeah, tech support. Pakikuha nung name, no? So and then with that po, wait a second, let me just close this. So nasaan na 'yan? Okay. Wait a second. Yeah, i-close. Ano gawin? Sa nanalo, message niyo lang yung aming Facebook page, ano? Okay, and then yeah, so then we're gonna contact you for the prize. Okay, so with that po, no, so we're gonna be ending the session, no. Maraming salamat po, no, so sa lahat ng umattend, no. Again, so meron pa kaming pre-webinar soon, so might be after 2 months or 3 months, no, on behalf of Xstructures, no. Also thank you Sir Paolo Bersamina for being one of the speakers of this webinar, no. Really high like very high information, no, sa seminar. And with that, maraming salamat po. We're gonna end the meeting na po, Sir Pao. Last words, okay, before we end.
Thank you for attending, everyone. So please check out yung namin, YouTube channel din namin.
Yeah. Okay, so with that, maraming salamat. Yeah. We're gonna end the session. Maraming salamat po. Keep safe and God bless. Thank you and good day. Salamat.